So we're going to have a look at the worked answers to the cumulative frequency questions that you were working on this week. So question number 1, we have the running times of some films, and we're going to need to draw a cumulative frequency graph in a moment. So that means we need to calculate the cumulative frequency, which can go in this column here. This column here, the number of films, is the frequency. So remember, cumulative frequency is a running total of the frequencies. So we have 0, 9, then 9 add the 35 from the 100 to 120 minutes gives us 44, then add on the 30, which gives us 74, then add on the 18, which gives us 92, and lastly add the 8, which takes us to 100. Now, when we plot our cumulative frequency graph on the next pair of axes, remember cumulative frequency is plotted on the vertical and the time in this case will be plotted on the horizontal. Plot the cumulative frequencies against the upper endpoints of each group. So there are 0 people in the group that takes us up to 80 minutes. So 80 minutes will be plotted here against a cumulative frequency of 0. The next cumulative frequency is 9, which is plotted against 100 minutes. So we find 100 minutes on the x-axis and then plot that versus a cumulative frequency of 9 on the y-axis. You will see this on the next page. So let's start plotting our cumulative frequency graph. I'm going to plot the points in red so you can see them nice and clearly. So remember, we have a 0 value of cumulative frequency against an upper endpoint of 80. So there's 80 and 0. Then we have 109, which is probably about there. Then we have 120 and 44, which is about there. We have 140 minutes and 74, which takes us up to there. Then we have 160 and a cumulative frequency of 92, and then 180 minutes and a cumulative frequency of 100. And we can then join up the points either with a smooth curve, or remember, you can draw a cumulative frequency graph by joining the points up point to point using a ruler and straight lines. So here we have our graph. Please make sure your sketch is a little bit neater than mine. Estimate the number of these films with a running time of less than 2.5 hours. So we need to convert 2.5 hours into minutes. So that's 2 lots of 60, that's your 2 hours, plus your half an hour of 30. So that works out to be 150 minutes. So what they want us to work out is if we plot 150 minutes, we find 150 minutes on the x-axis, so that's about here, and using a ruler, showing our working carefully, let's track our way up to the cumulative frequency graph, and then let's track our way across. So we want to know, and again, please do this with a ruler when you're doing this, how many films have a running time of less than 150 minutes? Well, it's this many films here, and that is probably about 83. You might have an answer which is about 82, 84, somewhere in between those, so possibly around 83. Question 2. We've been given the cumulative frequency graph and it's been drawn as a curve rather than straight lines point to point. Remember, both are okay. So how many men have a waist measurement of 85 centimetres or less? So we find 85 centimetres and then we track across horizontally to see how many people had a waist measurement of 85 centimetres or less, and that looks like 4 people if we read the y-axis, the cumulative frequency axis, carefully. Now, what is the median waist measurement? Well, how many people are there in total? The graph goes up to a maximum value of 40. So the median value is going to be found by looking at a cumulative frequency of 20, which is half of 40. Let's then go across and down to the x-axis, and that gives us our median value here, which is 101. Now, the interquartile range. Well, a quarter of the way through 40 is 10, so we need to go along here to find our lower quartile. I can read that from the x-axis there. So my lower quartile is equal to 93 approximately. And my upper quartile, well, 30 is 3/4 of the way through 40. So if I go across like that to the curve, down like that, I'll be able to read off my upper quartile, which is equal to 106. And so my interquartile range is 106 subtract 93, which comes to a value of 13. Question 3. Here is some information about the times in minutes that 80 teachers took to get to work. So we've been given these two columns here. Now one of these is of course for the cumulative frequency. So I'll put CF there ready for that. And this column here, you might like to use it for cumulative time. So the first time cumulatively is from 0 to 20 seconds. So 20 minutes. So how many teachers took up to 20 minutes to get to work? It's 12. I can then write the next time, not just the 20 to 40 minutes, which is the 32 people. I could think, well, how many people took up to and including 40 minutes overall? Well, it's the total of the 12 and the 32 people, which is, of course, 44 people. We're then looking at how many people took up to 60 minutes. So we add on this 25, which takes us to a value of 69. And then we're looking for how many people took up to 90 minutes overall. Well, it's the total of everybody, so it's 80. Now, cumulative frequency graph. Remember, you are plotting the cumulative frequencies here against the upper values of each time interval, like that. I'll plot them in red again so you can see them. So up to 20 minutes, that's 12 people. Up to 40 minutes, that's 44 people. Up to 60 minutes, that's 69 people, so that's there. And up to 90 minutes, that is 80 people, so that's going to go over there. Now, where does the graph start? Well, the first group starts at 0, so I can put a little cross there for 0. And again, I can either draw a smooth curve through the points like that. I've missed 2, so it's not as smooth as it could be, or I could join them up point to point. So this time I've drawn a smooth curve through the points rather than joining them up point to point with a ruler. Now you can't see it on this page, but the next question asks us to find out how many teachers, or estimate how many teachers took between 50 and 70 minutes to travel to work. So let's find 50 minutes first of all, and I'm going to draw a vertical line, use a ruler up to the curve, and then across like that. Now, what does that tell me? That tells me that if I read the y-axis, 56 people took between 0 and 50 minutes to get to work. Now, let's find 70 minutes on the x-axis. Again, use a ruler, track that across. What does this tell me? Well, this tells me that 74 people took between 0 and 70 minutes. So how many people took in between 50 and 70 minutes? It's this many people. It's the number of people in this gap over here, which of course is 74 people take away 56 people, which comes to a value of 18. So the answer to part B is 18 people. Question 4. We have the marks of 50 students in a test, and we've got to plot a cumulative frequency diagram. So here's the cumulative frequency column. Add up your cumulative frequency as a running total, and we should get to 50 at the end. So remember, you're always plotting cumulative frequency on the y-axis versus the top value, the upper value in each of these groups. So 60 marks. 2 people got between 50 and 60 marks. So I'm going to find 60 marks on the x-axis, plot that against 2 on the cumulative frequency axis. 5 people in total got up to 70 marks. So I find 70 marks and I plot that against 5 people. 25 people got up to 80 marks. So I find 80 marks and I plot that against 25, checking that I'm doing that carefully. 41 people got up to 90 marks, so find 90 carefully. And you may find it helpful to use a ruler and then plot that against 41. And then 50 people got up to 100 marks. So let's find 100 marks and let's plot that against 50. I'm just going to rub out that there. So again, either join the points up with a ruler or draw a smooth curve. Now, because the data starts with a mark of 50 here, I can plot 50 against 0 there. Now, the next part of the question asks us to find out how many students scored between 72 and 85 marks. Now, careful, because we're looking at the number of marks. I'm not interested in the cumulative frequency axis just yet. I'm looking at who scored 72 marks, who scored 85 marks. So 72 on the x-axis. So let me find that and I'll sketch that up like that. And then going across, well, it looks like 9 people scored up to 72 marks. Now, how many people scored up to 85 marks? So let's find 85 on the x-axis. So this value here is 85, this value here is 72. And let's go along like that. And I can see that we've got 34 people who scored up to 85 marks. So where are we looking? Well, we're looking for the people who scored between 72 and 85 marks. So that's these people here. So it's 34 take away 9. 34 people scored between 50 and 85 marks. 9 people scored between 50 and 72 marks. So the difference between those are the people who scored between 72 and 85 marks. So that comes to a value of 25. So my answer to part B is about 25. Question 5. We've been given a cumulative frequency graph. We need to use the graph to estimate the median mass of apples. So there are 50 apples. Our median apple is going to be our 25th apple. So find 25 on the cumulative frequency axis there. And then track downwards from when you hit the graph. Draw this on your diagram. Make sure your working is clear. And this takes us down to the median mass on the x-axis, which looks to be 106 grams approximately. Now, the last part of the question asks us to estimate, that means use the graph, the proportion, and that's an interesting word to think about, of apples with a mass greater than 115 grams. So what am I going to do? I'm going to find 115 grams on my x-axis. There it is. I'm going to draw that across to my y-axis like so, which gives me a measurement of 42. So that suggests to me that 42 apples have a mass less than 115. Remember, this 42 represents all these apples here, which have masses less than 115. So how do I find out the number of apples with a mass greater than 115? It's these apples here. So the number of apples with a mass greater than 115 grams is 50 subtract 42, which equals 8. But the question asks for the proportion of apples. So the proportion is 8 out of 50, which if you like, you can simplify down to 4/25, and if you want to, you can convert that to a percentage. It is 16%, which you can see if you multiply the numerator and denominator of that fraction by 4. But any of those answers is acceptable. So the answer to part B, 8/50, which is the same as 4/25, which is the same as 16%. That is the proportion.